Okay. That reminds me, anyone that has an incomplete from last quarter because of not being here for the last test, I think you're one, right, Emily? Or someone else, right? Okay, Bella. So you guys need to take that test preferably by Wednesday. Okay.
There's a quiz too.
Whatever. What are you missing? I don't remember. Let me check.
Yeah, it was a unit circle quiz.
It definitely has a
And I
one.
like a 46.
Yeah, it's a unit circle quiz and the trig unit circle test. So you guys both have a quiz and a test. Okay.
Are you going to be here after school today?
Yes.
Can I come and take the quiz after school?
Yes. Okay, so let's see here. Bri, what is the sine of 45 degrees?
Square root 2.
Okay, root of 2 over 2. What's the sine of 60 degrees, Mason? Right, and we know that because sine is the y value, okay? So today we're going to actually start to look at graphing the sine curve, okay? So by the end of the period, you'll be able to graph it on your own, a basic sine curve, and we're going to start with just plotting the basic curve. We're not going to look at any shifts. We call them phase shifts or vertical shifting today. We're going to do that another day. Today we're just going to look at, excuse me. Today we're going to look at just basic curving. Okay, so let's just get just a general understanding of some sine curves. So we're going to look at a couple of videos. Okay, I want to pause on that and look at that again because that's something I want to make sure you get. Okay, so we've got a smaller wheel, right? So the sine wave is representing the vertical distance, right? So if you look at the red one in the first 5 minutes, right? This is how far up the red one goes, right? So that's how far up the red one goes, right? In that same 5 minutes, this is how far up the blue one goes, right? If we look at the example that he's given us, okay, here's our wheel, and in his example, he said it's taking 20 minutes for each wheel to complete one revolution. So in 5 minutes, we go from this rest position up here to basically what would be the maximum height. In 5 minutes, the red one also goes from its rest position to its maximum height. So if we look at the actual wave, okay, in 5 minutes, they both reach their maximum height. In another 5 minutes, they're both at their rest position. So here, E is the rest position, okay. In another 5 minutes, they've both reached their minimum height. And then in another 5 minutes, they're both at the rest position again, okay. So it doesn't matter um, the size of the wheel. If it's taking 20 minutes to complete that revolution, then they're both reaching their rest positions at the same time. The difference is what we call the amplitude, which is the difference between the rest position, the height of the rest position to its maximum height. So in science, did you guys talk about amplitude way back when? Like maybe seventh or eighth grade, right? You have a wave, right? How many of you did that in science? Most science teachers, right? They take a rope and they show you, right? You didn't do that. I can see by your faces that you guys didn't do that, right? So if you have a rope, right, and you're waving one person on each end and you're kind of flexing the rope, right? It's like, right? But then when you stop, what happens? It tightens out, it straightens out. That's your rest position. The amplitude is how high or how low that wave goes, okay? Um, Amplitude directly relates to frequency, okay? I'm sorry, period directly relates to frequency, okay? The period of a wave is the time it takes to complete one full cycle. So in this particular example, the period of this wave is 20 minutes. It takes 20 minutes to complete one full cycle. If this, oops, go back, come on. If this Ferris wheel went around twice, what would happen with that graph? It would keep going and it would look exactly the same, right? It would keep going. Let me do this here. So here's back to its rest position. It would just keep on going and it would do the exact same thing. Okay, that's called periodic. So the period is 20 minutes. So in 40 minutes, we would see two of these curves. In 60 minutes, we would see three of those curves, okay? The period is directly related to the frequency, okay? So if it has a period of 20 minutes, then that tells us how frequently we will see the top of this wave. Okay, we're going to see the top of this wave how often? Every 20 minutes. So if you're a boater, this is frequency is somewhat familiar to you because they talk about with the wave frequency, right? There's a whole bunch of different things that they do, but the wave frequency refers to how many waves you're getting within a certain amount of time or a certain distance, right? So when you're looking at reports to determine whether it's safe to go out on your boat, do any of you boat? Okay, you're looking at reports to determine, you're not just looking at the height of the waves, are you? The frequency of those waves is important. When they're really close together and high, now you've got a pretty difficult situation, especially for our small boat, right? If they're higher, but the frequency is further apart, that's not as bad. You know, okay, so I'm climbing up the wave, but I'm coming down. I'm like, okay, I've got a little time before I'm going back up again. But when they're close together, you're like, it's rough on our little boats like mine, right? So that's that frequency, right? We need to understand what that means. Okay, let's get back here now then. Let's see. Okay, what do you think that'll look like? What's going to stretch out? The red one?
The red one's going to be stretched, the blue one's going to be compressed.
The blue one's going right. So the red one's going to be the same as what we've been looking at, right? So this is going to be completing a cycle in 20 minutes. So what the blue one, right, if I match it up, it's going to be compressed, which means actually I'm going to complete 2 cycles in that 20 minutes, right? Okay, I'm going to stop it there. Okay. Some examples of sine waves in the real world, because I know you like it, real world examples. Okay. Okay, here's obviously a Ferris wheel. To be honest, anything that has a wheel or a circle, right, is going to have a sine wave associated with it. So when we study movement with anything with a wheel, a bicycle, a motorcycle, a car, right? That rotation of the wheel, it's going to go through that sine wave, okay? And the sine wave is telling us the vertical component. So the sine wave is going to tell us the vertical component. And if we look at that bicycle wheel, right, as we go around the wheel, right, if this is my rest position, right, so as I'm traveling, this is the highest that it's going to go. We're back to the rest position. This is the lowest that it's going to go, right? What's going to help me understand the actual movement of the bicycle? Is that going to be sine or is it going to be something else? If sine is giving me the vertical position of
And
that
the
wheel,
cosine.
cosine is going to give me the horizontal position. Look at the connection there, right? We learned sine is y, cosine is x. Well, if you think about it, which one is horizontal movement? Cosine, right? X is the horizontal movement. Y is the vertical movement, right? That's the up and down. So when you're thinking about what we learned just in math class and how it applies to the real world, we've got 2 components, right? Another example is in the medical field. All sorts of graphs and charts, okay, demonstrate they call them sinusoidal curves. Okay, sinusoidal curves. Um, Other examples look very similar to this would be sound waves. Okay, if any of you play a musical instrument, you would see that sound wave. Um, so that's another example of a sinusoidal curve. Okay. Okay. Um, get a blank document here. One of the cool things I really enjoy physics. Um, I have had the privilege of teaching physics on some occasions, and of course, I teach it from more of a math perspective. But one of the things I really enjoy in physics is when we look at projectile motion, right? So, for instance, let's just say that we're kicking a football, right? Okay, so we kick our football, right? Okay, that's not a very good project. It's not going to drop off quite that much like that. But anyway, when we kick a football, right, we have both a vertical motion and we have a horizontal motion. Okay, now the angle that we kick the ball at is going to determine how high that ball goes, right? So, depending on the angle, we already learned from our unit circle, the smaller the angle is, the greater the x, whoops, didn't mean to do that, the greater the x component is. The bigger the angle, the greater the y component. Well, that makes perfect sense when you look at an example like this, right? If I need to kick that ball further, it's not going to be as high, is it? Because I need to get more horizontal distance, right? I need to get more distance like this. So I'm going to cut down on the angle. That's why when you watch a field goal kicker, if they're kicking from the 50-yard line, okay, they're going to be kicking bullets, right? They're going to be trying to get as much distance as they can. Well, when we look at something like this where we have a projectile, right, we would figure out, okay, what velocity is this ball being kicked with? And then we would break it down into its horizontal component. So we would take the cosine of that angle and we would break it down into its vertical components to find its, break it down into its sine to find its vertical component. Okay. Okay. So let's get back. You have some notes that we started before break. If I can get it to come up. There we go. Your trig notes. So let's take a look at that for a moment. And I'm looking at page 22 of your trig notes. Okay. Okay, actually, you know what? I'm going to give you just a few minutes to do this yourself. Let's see here. All right, so my graph paper is a little bit different, but I don't want to load two of them in here, so that's fine. Okay, so when x equals 0, what does sine equal? 0. Sine of 0 equals 0, right? When x equals pi over 4, what does y equal? The sine of pi over 4. What was the sine of pi over 4? Square root of 2 over 2, which is 0.71. So we're looking at right about there, right? When x equals pi over 2, what does the sine of pi over 2 equal? 1. When x equals 3 pi over 2, right? This is 3 pi over 2. I'm sorry, 3 pi over 4. Sorry about that. What does sine equal? Pi square root of 2 over 2, which is 0.71. Right? We're just plotting points, right? So when x equals pi, what does the sine of pi equal? 0. Remember I said you have to know that unit circle, right? Okay, now let's see. Here we're looking at 5 pi over 4. So sine of 5 pi over 4 is negative root 2 over 2. So we're looking at negative 0.71. Three pi over 2. So that's right here. What's the sign at that point? Negative 1. And here we have 7 pi over 4. So sine of 7 pi over 4, that's over here. So that is also negative root 2 over 2. And then the sine of 2 pi, that's right here. So that is 0. So our curve looks like this. That's our sine curve, okay? Okay, if you look at this curve, right, this is the graph of y equals sine x. What's the period of this curve? How long does it take to complete one full cycle? Right, 2 pi. 2 pi is my period. Takes me 2 pi units to complete one full cycle. What's the amplitude? 1, yes. Okay, the amplitude is 1. Okay, I'm going to show you another video just because I think it's kind of a cool video for us weird math people. Like how I included you in that? I love that. Right, you got to go back because I think it's such a cool thing. Right, look at this. Like if you follow, okay, pick this pink one here. Right, as it moves, if you follow it, that little pink circle is just moving right on this straight line. Okay, watch. It's just so cool. Love that pink one. Just moving on that straight line there. Cool. I also love his accent. It's like the British version of coal, isn't it? Okay. I think that this is such a good explanation of the vertical and the horizontal components. As you watch that blue dot move around the circle, you can see that it's matching. This is the vertical component of it, and then you have the horizontal component of it. Okay, so see how that's periodic, right? So, excuse me. Right, so he started here, right, and as it was moving, let's see if I can go back here. Okay, so here it is at 0, 0, right, and as it's moving up, he's plotting the points. So there's the blue ball, right? And here we're plotting this. So this is representing the height of it. And then it starts to come back down again. So one full time around the circle, okay, one full time around the circle, we have one period. And we go around the circle again, and we have two periods. Okay. All right. So I thought that was kind of a cool demonstration. It's so important that you recognize that sine is the y coordinate. Okay. Let's look at how to actually graph this on your calculator. Oy vey. So please take your calculator out. Very important that you know how to do this. So take it out, please. Oops. Okay, so first we're going to make sure that we are in radian mode because right now we're working in radians. Okay, so change your mode to radian. Okay, and we're going to just type in sine x, sine parentheses x. Okay, we're going to go to our window and we're going to use an x min of 0. What's our x max going to be? Look at your graph that I gave you. How far out did you go for x? 2 pi. So we're going to type in 2 pi. So 2, and then pi is right here. So we have to use the shift button for pi. Okay, now when I press enter, it's going to convert that to decimal. Okay. Now my intervals, my scalar, so how much does each mark on my graph represent? Well, I want to match what you have on your graph, right? So if we look there, I think you have the same graph except you don't have the left side here. So we're going to go from, what is this mark representing? What does each mark? Pi over 4, right. So our scalar is going to be pi over 4. That way, when I look at it on the graph, I know that every mark is representing pi over 4. Okay, now the y min and max, I'm just going to go negative 3 to 1. I'm sorry, negative 3 to 3, not 1. Okay. How high did it go on our graph, by the way? What was the maximum? 1. Right. So negative 3 to 3 is going to give me plenty of space. Okay, so let's go ahead and graph this. And there we have it. Okay. Now, if I change my window to go from 0 to 4 pi, what do you think is going to happen? It's just going to repeat itself. So here was 2 pi right here and 4 pi. So we get 2 curves. Okay. What do you think is going to happen if we go? Question? Is everybody okay with the calculator? Okay.
There we go. I was in degree, or I was in degree and it wasn't working.
Okay. Got to be in radians. Yep. Good. By the way, we can do it in degrees if your graph happens to be in degrees. So what we would do, first change your mode to degree, right? So if I wanted to graph in degrees, I have to adjust my window. So instead of going from 0 to 2 pi, what would I go to if it's in degrees? 360 degrees. And each mark on the graph is representing 45 degrees. Okay, now I'm going to get the same graph in degrees. Okay. All right, so what I'm going to do, I'm going to give you another blank sheet. And I want you to graph y equals sine x from negative 2 pi to positive 2 pi. Okay. Y equals sine x from negative 2 pi to positive 2 pi. Okay. So the last one we did, we graphed what was our domain. In the last one, what was our domain, or what was the interval that we used? Come on, guys, wake up, wake up, wake up, wake up. What interval did we graph over on the last one that you did? 0 to 2 pi. What interval are we graphing now? Negative 2 pi to 2 pi. Yes. Okay. So go ahead and graph that one. Okay. Let's do it. So we're going from negative 2 pi to 2 pi, right? This is actually really easy. This is periodic, right? So what should be happening over here? This should continue going in the same path. It's going to look like that. Okay. Now, what I want you to notice is how quickly I did that, right? When I'm graphing a sine curve, these are actually really easy to graph. I'm going to show you the shortcut way of doing it. Sine curve, I know, has a period of 2 pi, and it has an amplitude of 1. So first off, because it has a period of 2 pi, it's going to start at 0 and it's going to end at 0. Halfway between those 2 points, it also hits 0. So these are basically our x-intercepts. So what do our x-intercepts actually represent when you think about the curve itself? Think about that rope that I was telling you about, right? We're swinging the rope up and down. What do those x-intercepts represent? Say again? Starting point, or it's, what did we call that when it was just straight? The rest position, right? So that's its rest position when it gets back to the rest position. When we looked at the Ferris wheel, right? When we looked at the Ferris wheel, it's like, okay, we were in a little cart right here, right? This is our rest position. We're starting position. This is our maximum height here. Here we are back to our starting position. This is our minimum height. And here we are back to our starting position. So in one full revolution, I have my starting position 1, 2, and 3 times, right? So this is where I start. This is on the other side of the Ferris wheel at the same starting position, and this is back at the very beginning, okay? Okay, so we take our period, put our zeros there, and then we cut it in half and put a 0 there. Now, in between these two zeros, in between this point and this point, I reach my maximum height. Halfway in between. Now, what's the maximum value of sine x? 1. So in between, I reach a maximum of 1. Okay. In between this point and this point, I reach my minimum height, which is what? -1. So I'm just going halfway. I'm just cutting it in half, right? So I plotted my two zeros based on the period, and then halfway I put another 0. Halfway between each 0, well, I should say halfway between the first set of zeros, I have my maximum. Halfway between the next two zeros, I have my minimum, and there's my curve. Okay. If I want to extend that to -2 pi, okay, again, period is 2 pi units. So I put my zeros here and here. Halfway between, I put my 0. Okay. Now I have to follow this, right? Halfway between, right? I'm going down now because we were up, we were at a maximum here, so this has to be a minimum. And then over here, halfway, I've got a maximum again. See how quick and easy that is, right? Really simple. Okay. Okay. What do you think will happen if we have y equals 3 sine x? The maximum is 3. Good. So does my period change? No. This is, remember we looked at the difference in the wheels? This is just a bigger Ferris wheel. Still taking the same amount of time to go round. So my period's the same. So we go 0 to 2 pi. We cut it in half and we put a 0. Halfway between the first two zeros, we have a maximum. In this case, it's 3. Halfway between the next two zeros, we have a minimum. So it's -3. So there is my sine curve. Okay. So the amplitude is this number right here in front of the sine. Okay. Now, the formal form of a sine function looks like this. Let me just get this stuff out of here. Okay. Okay. Y equals A sine bx minus c plus d. That's the form of your sine curve. Okay. Now the A, or I should say the absolute value of A, is the amplitude. Now we're not talking about A being negative right now. We'll look at that later. Okay, so if there's a 3 in front of it, that means it has an amplitude of 3. Okay. The period is found by taking 2 pi divided by b. So when we looked at y equals 3 sine x, here was my A, that's my amplitude of 3. Now the b in this case was just a 1. So my period was 2 pi divided by 1, which is 2 pi. But let's change that up now. Let's make this a 2x. Okay, so now I have an amplitude of 3 and I have a period of 2 pi divided by what? 2, which is pi. My period is pi. So what does that mean? It's going to complete one full cycle. And how long will it take to complete one full cycle? Pi units. So I'm going to start at 0, and where am I going to end my cycle? At pi. Okay. Halfway in between, right here at pi over 2, I hit the 0 again. See if you can finish this graph, and I want you to go from 0 to 2 pi. Go 0 to 2 pi. So when you do this, you're going to graph one full cycle first, and then you'll extend it. Okay, so halfway between 0 and pi over 2, where am I going to put a point? 3, yeah, that's its amplitude. Halfway between pi over 2 and pi, we're down at -3. So there's my first cycle. There's my first period. Okay, now I'm just going to extend it. I'm going to go another pi, so I'm going to do the same thing again. Right? From pi to 2 pi is one full period. Halfway in between there, there's my 0. I'm going to have a maximum up here, a minimum down here, and there we go. Okay. All right. So how do you make your graph by yourself? So what you have to do, right, we figured out our period. How many points are important to us? We have 1, 2, 3, 4, 5, right? I need 5 points that are important to me. So sometimes coming up with the appropriate legend for your graph is a bit of a struggle, right? So I have pi units. So what I do, basically, I take whatever my period is and I divide it by 2. Okay. Then I figure out, okay, what do I need to divide that by 2? So basically, I divide by 2 twice, right? So I took my period, I divided by 2. Now I'm going to divide by 2 again, or multiply by 1/2, right? That tells me that I want each unit to be pi over 4 units, or each mark to represent pi over 4. Okay, so for instance, let's pretend that our graph was y equals 2 sine 3x. Okay, 2 sine 3x. Okay, y equals 2 sine 3x. Okay, what's our amplitude? 2. All right, what's our period? 2 pi over 3. Our period is 2 pi over 3. So obviously I'm going to have to change my units here. Okay. My graph. Okay, so my period is 2 pi over 3. So I'm just going to make this 2 pi over 3 right here. Okay. So now I have to figure out my mark. So I need to go halfway. So I'm going to do half of that. So I'm looking at 2 pi over 6, which is pi over 3, right? So halfway, we're going to make that pi over 3. Everybody follow me? Okay, now we need to go halfway again. That's pi over 6. So halfway again, right here, pi over 6. Okay, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Okay. Okay, so let's do our graph. 0 to 2 pi over 3. Halfway in between is another 0. And then I go up to my max. In this case, it's 2. And I go down to my minimum, which is negative 2. And there's my sine graph. Okay? Okay. I have a worksheet for you to do. Okay. So what have we done today, right? We looked at just a general sine curve. Okay, we looked at amplitude. We discussed period. We discussed how to go ahead and calculate the period or how to determine the period. We looked at how to graph it on our calculator so we can double check ourselves. Okay. This worksheet, you need to do it by hand. Please don't use your calculator on the worksheet. You need to be able to do this by hand. In fact, when we have a quiz on this, it will be without a calculator. Okay. When we have a quiz on it, you will not have the unit circle in front of you. All right. Okay, so we know how to graph a sine curve using the amplitude and the period. So that's what you're going to do on this worksheet. It's 2 pages. The first page is in radians. The second page is in degrees. Okay. 2 pages. Yes. Yeah. Let me just hand these out, and I'll be right there. Questions for me, anyone? This is not too bad, right? Because we are just starting. But... yes, question. Are you in degrees or radians? I think they are. I think if you were to zoom in, I think you would see that they are. Can you see it again? Yeah. I think what we're seeing is just, I think it's the calculator, the way it's doing the points. I think that 1000x has so many points in there that we're getting a little bit of discrepancy going on. Yeah. And that's why it's so important to understand the function that you're graphing, because you're gonna run into it often when you're graphing calculators. Okay, questions? Just your first look at it. Anyone have any issues with it? Feel free, if you need to draw a different graph or change the values, you can do that if you need to.